Okay, so we've been using the trig ratios to solve problems involving right triangles, and now we're going to solve a few problems in which we actually have to draw the triangle first before we can solve it. And before we do that, we're going to talk about two particular types of angles, angles of depression and angles of elevation. So the first one we're going to look at is called the angle of elevation, and the definition of angle of elevation is an angle formed by a horizontal line and the line of sight to an object above the horizontal line. Now, a couple of things in particular that we're going to look at here: line of sight and the object above the horizontal line. So take a look at this picture here. Here we have a horizontal line. This is my horizontal line down here. It kind of represents the ground. And you can see I have an object here above my horizontal line. Up above the ground is this plane. So this is my object above the horizontal line, my airplane. So this line here, where you see you've got this person kind of standing down here on the ground, this observer, well, this observer is looking up at the plane, and this line here is called the line of sight, or the line of sight of the observer. All right? In other words, the observer is looking up at the plane, and that line, imaginary line if you want to think of it that way, that line of sight goes from the observer up to the plane. So the angle of elevation, according to our definition, is an angle formed by a horizontal line and the line of sight to an object above the horizontal line. So here's our horizontal line, here's our line of sight. This angle right here is our angle of elevation. So let's take a look at how we might use the angle of elevation to set up and solve a problem. So example number one from your notes, it says, a person is standing 800 meters away from the base of the Chrysler building in New York. The angle of elevation to the top of the building is 21.8 degrees. How tall is the building? Okay, so we need to draw a picture. Person is standing 800 meters away from the base of the Chrysler building. Okay, so here's my Chrysler building, and a person is standing 800 meters away. So here's my person, 800 meters away. Here's the Chrysler building, and I'm going to assume that the Chrysler building forms a right angle. It's standing straight up and down. It's not leaning. The angle of elevation to look up to the top of the building is 21.8 degrees. Okay, so if this person down here on the ground is looking up at the top of the building, this then is the angle of elevation. Here's my horizontal line. Here's my point up above the horizontal line, the object, if you want to think of it that way. And so my angle of elevation is this angle right here, and I'm told that angle of elevation is 21.8 degrees. How tall is the building? So I'm looking for this value here, the height of the building. Or you can see here I've essentially drawn a right triangle, and I'm looking for the length of this side of the right triangle. So now I can set this up just like I did all my other right triangle problems. I've got an angle. I'm looking for the opposite side. I have the adjacent side. Well, that means I'm going to be using my tangent ratio, which is opposite over adjacent. I fill in my information. Tangent of what angle? 21.8 degrees is opposite over adjacent. That's x over 800. I take the tangent of 21.8 degrees, and I get 0.39997 equals x over 800. I'm solving for the side of a triangle, which means I'm going to solve it using a proportion. And I have 1 times x is x, and 800 times 0.39997 is 319.98. So the building is, and let's see, this is in meters, 319.98 meters tall. right, let's take a look at example number 2. A ramp is 120 feet long and rises vertically 15 feet. Find the angle of elevation of the ramp. All right, so let's see. I need a picture. Let me draw. Here's my ramp going up. It says my ramp is 120 feet long and rises vertically 15 feet. Okay, so let me draw. See, this is going to be the ground down here, and my ramp rises vertically 15 feet. So this is 15 feet right here. Find the angle of elevation of the ramp. So the angle of elevation is going to be the angle formed by my horizontal line and the line of sight. If I want to think about a person standing down here on the ground, the line of sight for this person to look up to the top of the ramp. So this is my angle of elevation, and that's what I'm looking for, so I'll call that x degrees. All right, so again, I have a right triangle. I've got an angle. I know the opposite side. I know the hypotenuse. So I want the trig ratio for opposite over hypotenuse. That is sine. I fill in my information. Sine of what angle? Angle is x. Opposite is 15. Hypotenuse is 120. Now, since I'm looking for an angle, I'm going to be using my inverse sine function. Inverse sine of 15 over 120. And if I punch that into my calculator, I get that x is 7.18 degrees. And that is the value of my angle of elevation. So you can see all we're doing is we're doing the exact same types of problems we were doing before, except now we actually have to draw the triangle based on the information that we're given. Okay, now let's talk about angle of depression. The definition of angle of depression is an angle formed by, again, a horizontal line and the line of sight to an object below the line of sight. That should say below the horizontal line. All right, so an angle formed by a horizontal line and the line of sight to an object below the horizontal line. So again, let's take a look at this picture if you have in your notes. We've got this building here, and again, I'm assuming that the building is straight up and down, so that forms a right angle. And let's say I've got a car parked over here on the street below, on the street here away from the building somewhere. And let's say I've got a person, an observer, standing up here on the top of the building, and this observer is looking down at the car. All right, so in this case, here's my line of sight right here. And now the thing that is different about angle of depression and angle of elevation, remember in the angle of elevation our horizontal line was this line down here on the bottom. Well, for angle of depression, our horizontal line is going to be this kind of imaginary line that's up here at the top of our picture, because notice the angle is going to be formed by a horizontal line and an object below, the line of sight to an object below the horizontal line. So my angle of depression, here's my horizontal line. It's this line up here, this imaginary horizontal line. My line of sight is this line right here from the observer looking down at the car. So my angle of depression is this angle right here. So you can see my angle of depression is formed by a horizontal line and the line of sight to an object below this horizontal line. Now, the thing that kind of makes the angle of depression a little bit more challenging than the angle of elevation is notice that in my picture here I have a picture of a right triangle, but notice my angle of depression is not one of the angles inside my triangle. It actually lies outside of my triangle. Well, it turns out that's not as big a problem as you might think, because you'll notice this horizontal line, my kind of imaginary line up here at the top, and this horizontal line down here, the ground, these two lines are parallel. And I have a theorem that I learned when we studied our unit on parallel lines that says if I have two parallel lines cut by a transversal, and now you can think of this line of sight as a transversal, then what I have here with this angle and this angle, these two angles are alternate interior angles. So if I have two parallel lines cut by a transversal, then I know that alternate interior angles are going to be congruent. So whatever the value of this angle is, that's also the value of this angle. And when we draw our pictures in these next two examples, we're going to be using this angle since this is the angle inside the triangle. And so once we have this angle, that's the same as the angle of depression. So let's take a look at a couple of examples using angle of depression. So example number 5. From the top of a lighthouse, an observer notices a boat and finds the angle of depression to be 12 degrees. Okay, let's start with that. Top of a lighthouse. Okay, so I need a lighthouse. Here's my lighthouse. From the top of a lighthouse, an observer notices a boat. So let's say here's the ocean out here, and here's the boat on the ocean. An observer notices a boat and finds the angle of depression to be 12 degrees. Okay, well I know from my definition that the angle of depression is an angle between a horizontal line and the line of sight to an object below the horizontal line. So here's my angle of depression, and my angle of depression, I'm told, is 12 degrees. If the boat is 900 feet from the bottom of the lighthouse, so the boat is 900 feet from the bottom of the lighthouse, what is the height of the lighthouse? So again, I'm looking for this value here. Again, I'm going to assume that my lighthouse is standing straight up. It's not leaning over, so I've got a right angle here. So once again, I have a right triangle. I'm looking for this side of my right triangle. I know this side, and my angle of depression, since this angle is the same as this angle, they are alternate interior angles, I know the value of this angle is 12 degrees. So I just have a right triangle. I know this angle. I've got the opposite side that I'm looking for, the adjacent side that I have. I can use my trig ratios to set this problem up. Opposite over adjacent, that's tangent. I fill in my values. Tangent of what angle? 12 equals opposite is x. Adjacent is 900. I use my calculator to find the value of tangent of 12 degrees, and that's 0.213. I put that over 1 so that it looks like a proportion. I cross multiply. I get 1 times x is x, and 900 times 0.213 is 191.7 feet. Example number 6. The angle of depression of a car from a hot air balloon basket is 40 degrees. Okay, so let me see. I've got a hot air balloon. There's a hot air balloon, and here's my basket. Hot air balloon, the angle of depression of a car from a hot air balloon basket is 40 degrees. The balloon is directly over a water tower. Okay, let's see. A water tower down here. And here's the ground. So the balloon is directly over a water tower that is 5 kilometers from the car. So my water tower is 5 kilometers. Here's my car over here. And my water tower is 5 kilometers from the car. Okay. The angle of depression of the car from the hot air balloon basket, my angle of depression is 40 degrees. Okay, so angle of depression means the angle between a horizontal line and the line of sight to this object below the horizontal line. So here's my angle of depression. Angle of depression is 40 degrees, which means this angle down here is also 40 degrees. And it says find the direct distance from the balloon to the car. Okay, so I'm looking for this distance right here. How far away is the balloon from the car? I'll call that x. Again, I'm going to assume that this is a right angle because I'm assuming that my water tower is standing straight up. It's not leaning over. So once again, I have a right triangle. I know this angle. I know the value of the adjacent side. I'm looking for the hypotenuse, so I can set up a trig ratio to solve this problem. So let's see. I want adjacent over hypotenuse. That's cosine. So I need to fill in my values here. Cosine of what angle? 40 degrees. Equals adjacent over hypotenuse. I find the cosine of 40 degrees, which is 0.7660. That equals 5 over x. I put this over 1. I'm going to solve this using a proportion. 1 times 5 is 5. Equals 0.766 times x. I need to divide both sides by 0.766. 0.766 cancels out over here, and I'm left with x equals 5 divided by 0.766, which is 6.53 kilometers. Okay, now there are a few other examples. I believe you have examples 3 and 4 involving angle of elevation, and then examples 7 and 8 involving angles of depression. So you're going to have to draw the picture first, fill in the information, label your picture with the information that you're given, and then set up and solve using one of your trig ratios. And we'll take a look at these examples tomorrow in class.